now, the moment you've all been waiting for. Let's go over the Unit 2 practice test on exponents and scientific notation. Here we go. Number 1, we are asked how many times larger than this is this. So this is going to go in my numerator, and then the smaller one's going to go in my denominator. This had as much to do with the words as it did the numbers, because you had to understand that if something's larger, it goes on top, then the smaller one goes on the bottom. 6 divided by 2. So when we divide things in scientific notation, we divide the numbers. 6 divided by 2 is 3. And then when we divide things with the same base, we subtract exponents. Yes. And 6 minus 3 is 3.
Yeah, I got that right.
So that would be B. Okay? Number 2. How many times smaller is the mass of the water drop in the elephant? If I want to know how many times smaller it is, I need to do the bigger divided by the smaller. Okay? And so when I do this, I divide the numbers. 3 divided by 1 is 3. And 10 to the 6 minus a negative 6. Minus a negative is plus a positive. So then I get 10 to the 12. So how many times smaller is the water drop? 3 times 10 to the 12. How many times bigger is the elephant? 3 times 10 to the 12. Okay. Number 3. Same dealio, similar anyways. What is, if we have a that many gallons of water and that many seconds in a day, I need to multiply those together. So I have 8.6 times 10 to the 4th times 7.5 times 10 to the 5th. And when I multiply the numbers together, what do I get? Let's find out. When I multiply the numbers together, I get 8.6 times 7.5, and I get 64.5. And then when I multiply things with the same base, I add exponents. So 4 plus 5 is 9. But is that number in scientific notation? No. So I need to make it smaller by 10. So I need to make this bigger by 10 so that it's still the same value. And then I get my right answer. Yep. The answer should be in scientific notation. Number 4.
I did that times. Because I thought we were doing like times.
We did times.
So I did times the exponents.
Oh, yeah. Okay. Learn from that mistake. All right. Next one, we're going to go ahead and divide. So we're just going to do this divided by this. So I divide my numbers, and then I subtract my exponents on the powers of 10. So 9.25 divided by, so let me go ahead and clear this, 9.25 divided by 1.85, and I get 5. So it's 5, and then when I divide these, 7 minus 4 is 3. When I divide things with the same base, I subtract exponents. Okay? Number 5, we are adding. So I need to make the powers of 10 the same. So if I change this to 10 to the 6th, I need to make this smaller by 2, so I have to move the decimal 2 to the left. And I'm adding it to this, so 6 plus 0.02 is 6.02. Then my power of 10 stays the same once I make them the same, so that's D. Okay, any questions on that? Great. Next page. Okay, when I multiply things with the same base, I add exponents. When I divide things with the same base, I subtract exponents. That'd be 10 to the 12th. Pretty basic. Get those gimmies right. Here, when I multiply numbers like I've always multiplied numbers. 3 times 2 is 6. And then I x to the 4 plus 5, because when I multiply things with the same base, I add exponents. So that'll be 6x to the 9th. Okay? When I divide things with the same base, I subtract exponents. So that's negative 4 minus 1. Okay, Sam, this might be one that you want to... Okay, so minus 1 is plus a negative 1, and you get k to the negative 5th. And then to make a negative exponent positive, I have to put it under 1. Okay? So that goes back to the integer rules. Whenever I have subtraction in integers, I always add the opposite. Number 10, if I have a power to a power, I multiply the powers. That's the only time we multiply powers. Okay? Because remember, 3 to the 5th squared means 3 to the 5th times 3 to the 5th, which is 3 to the 10th. So 2 times 5 is 10, 5 plus 5 is 10. So you could really do that one either way if you multiply it out. Number 11, what does this simplify to be? Inside parentheses, we get 4 squared to the negative 2, which is 4 to the negative 4, which is 1 over 4 to the 4th, which is 1 over 256. What are all the equivalent expressions over here to that? A and C. Because what's negative 10 plus 6 would be negative 4, and this is that quantity as well. So it would be A and C. So whenever it says select all that apply, make sure you look at all the options. Got it? Okay, you get half off. Good question. This would be worth, either I'd make this worth 2, and you get 1 out of 2, or I'd make it worth, I'd probably make it worth 2, so you miss 1. Okay? All right, number 12. What does this have to be to get 4 to the 15th? Well, when I multiply things with the same base, I add exponents. So 5 plus what is 15? 10. Pretty basic. 13. What does the E mean? It means times 10 to that power.
Yeah.
What would that be if I multiplied it out? Well, I need to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, comma. 1, 2, 3, comma. 1, 2, 3, comma. 41 billion. Okay, 14. Same dealio. 1.73 e to the negative 6. Okay, those should be gimmies, I hope. That's supposed to be really, really, really easy. And then what would that be? Well, it'd be 0.0000173. 1, 2, 3, 4, 5, 6. Yep, that's it. Okay? So those would be worth 2 points. 1 each. Yes, Ellen. Oh, sorry.
Yeah, I was like, no. Oh, maybe plus 2. Oh, wait, and I got 20. No.
Good job. Okay, 15. Again, here we're dividing, so I'm going to divide those, and I'm going to get 50 times 10 to the negative 7 minus a negative 5. It's the top minus the bottom. Whenever I see minus a negative, I do plus a positive. So it's 50 times 10 to the negative 2. Is that in scientific notation? No. So I have to make that smaller by 10. So I have to make this bigger by 10. So when I add 1 to negative 2, I get negative 1. That was it. That one was a little more involved. That was one of the tougher ones we've had. So you got that right. Good job. Okay, B on this one, you multiply these together and you get what? What are those two numbers multiplied together? Huh? 7.56. And then I add exponents. 12 plus negative 10 is 2. That was pretty basic. Letter C, we have to make the powers of 10 the same. So if I make that bigger by 2, I have to make this smaller by 2. Then I add those two numbers together. 4.87 plus 4.87 plus, what? 4.87 plus 0.0523, and I get 4.9223 times 10 to the 11th, because I need the powers of 10 to be the same. Same dealio when I subtract. If I make this bigger by 2 places, I need to make this smaller by 2 places. And when I do that, I get 1.19 minus 0.037, 1.153. Powers of 10 stay the same. 17. Divide.
Wait, I got for the one that you just did. I got 1.5, 1.1528. You round?
Well, when I did it,
Is that how you got 3?
no.
You didn't round.
Yeah, how'd you get, like,
I got 1.15.
cause I moved the 2.
Okay, let's try this again. 1.19, maybe I typed it in wrong, minus 0.0372.
Yeah, I got 1.
Oh,
Yeah, see?
that's weird. Okay. So what was it again? 1.1528 times 7. Okay, thanks. Okay. When I divide things with the same base, I divide numbers like I always have. 21 divided by 7 is 3. M to the 6 minus 2 is base piece cake. Think about this. This is 3 times 7 times M times M times M times M times M times M. It makes sense over 7 times M times M. Divide out common factors, right, Zach? And I get 3M to the 4th left. You can do it that way if you want.
I didn't do it that way.
Oh, you got to.
I didn't do.
Okay, 16.
Divide from the bottom.
When I multiply things with the same base, I add exponents. 11 plus 9 is 20. Right, Casey? Okay. When I multiply numbers like always. 5 times negative 2 is negative 10. P to the 3 plus 6 is 9. Okay? Hopefully y'all got that right. It's pretty basic. If you have 8 squared to the 4th, I multiply those powers. It's 8 to the 8th. Remember, if I have a power to a power, then I distribute that power. So, just to get this a little bigger here, that means that this is a 1 and that's a 1. So I'm going to multiply this exterior power by the powers on the inside, so I get this. So I would accept 5 to the 6, W to the 6, or whatever 5 to the 6 is multiplied out, 15,625. All right? Okay? Okay, the next one, the same dealio. This is 1 and that's 1. So you'd have 0.4 to the 4th, x to the 4th, or
0. You say 0.4 to the 4th times.
or what is 0.4 to the 4th? 0.0256 x to the 4th. Okay?
If you put a 0 in front of the 0.4, will it still count?
Yeah, of course.
Okay.
Bonus.
Oh god.
Okay? Let's simplify first. Yes, Zach? Nope. But you can put anything off of this in your toolkit.
Oh, I'll probably.
Okay, so distribute. 3 to the 3rd, r to the negative 9. Watch what I do first. Watch what I do first. I do everything step by step. I do the first step. I need to distribute this power. Because it really isn't that hard if you do one thing at a time. Step 1, simplify everything. Step 2, let's multiply these out. Now let's multiply numbers together. 27 times 36 times 2. 27 times 36 times 2. 1944.
Right.
Okay? Negative 9 plus 2 is negative 7 plus negative 1 is negative 8. What do I do if I have a negative exponent? Put it under 1. Okay, here's your bonus answer. Again, all it did was require you to take a couple extra steps. It's not that you could not have done that. So please don't see the word bonus and think, I can't do this. I give you a bonus for a chance to make up for something you did wrong.
I got 30.
Okay,
I got 36.
so just to reiterate, tonight, after you go through and take any notes off your practice test, please go to Google Classroom, okay, to the post that I put in for your class, and you can see all of the work I did for you. You have your Jeopardy, which we're going to work on now. You have toolkit if you want to look through and add any notes that you want. to add, then we have some additional worksheets or Khan Academy help. Okay? No excuses.
No excuse.